Welcome to Subnetting Level 14, Designing IP Address Schemes Using VLSM. So you might be wondering, what does dinner time have to do with subnetting? Well, if you've ever had to share a pizza with other people before, you might have had someone in the group who was really hungry, and they possibly ate half the pizza. And then there was someone that was moderately hungry and they ate maybe a fourth of the pizza. And then maybe there was someone who wasn't all that hungry and just had one slice. So, just as people have different nutritional requirements to fulfill their hunger, networks have different requirements as well. Every network may require a different number of host IPs. In this example, I have a network, we'll call it LAN A, that requires 5 host IPs. Then LAN B requires 90 host IPs for the devices in that network. And LAN C requires 20 host IPs for the devices in its network. We can give each one of these networks either a large or a small range of IP addresses using VLSM, which stands for Variable Length Subnet Mask. It basically means giving a bigger slice of the pie to networks that need it and a smaller slice of the pie to networks that might need smaller number of IP addresses. So let's take a look at the process. Step 1, list the networks from the largest number of required hosts to the smallest number of required hosts. This is a very important step. So LAN B requires the most, so it goes first in our table. Then LAN C requires 20, that's the next largest. And finally, LAN A only requires 5. So that's all you have to do for step 1. List them from largest to smallest. Now, step 2, we need to identify our starting point. So we have been assigned the network 192.168.5.0/24. Using VLSM, subnet this network to create a range of IP addresses for each of the 3 LANs. We are going to use our subnetting cheat sheet to help us get started. All right, step 3, right size your networks. So remember, we've already listed them in largest to smallest order, and we need to now identify the CIDR notation and the total number of IP addresses for that particular network. So let's take a look at LAN B. LAN B requires 90 IP addresses. So we need to find out what type of address would accommodate 90 hosts. We are going to be focused on this part of the table right here, the number of hosts that we need. So let's take a look. 90, if I start with the 24/24, 254, that's kind of big. Then we go down to a /25, 126. Well, 90 would fit in there. We go one more to a /26, only 62 host IPs. That's not enough. So the best choice is a /25. /25 is what we call right-sized for that network. So it does have 128 total IPs, so we'll have a few extra, and that's okay. So that's our choice, is a /25, and we record that in the table. Now LAN C, 20 required host IPs. Once again, I'm going to take a look at those host IPs, and I'm going to find out that /26 is a little big. I go to a /27. There's a that accommodates 30 hosts. That could work. I go down one more. /28 is 14 hosts. Ooh, that's too small. So I'm going to have to choose or settle on a /27. So /27 will accommodate 30 hosts, which is more than enough for the 20 that we need for LAN C. So I'm going to record in my table that we've decided to make it a /27 network and that it has a total of 32 IP addresses. Now, the last one is LAN A. We need 5. As I look at the table, I can see that the best choice would be a /29. It supports 6 hosts, so I mark that in my table, a /29, and I mark that it has a total of 8 IP addresses. And you're going to see why we need to know the total IP addresses. That's actually going to help find our network IPs, our starting points for each of these LANs. All right, step 3, done. Let's move on to step 4. Step 4, we're going to slice up the subnetting wheel and we're going to identify the network IP of each subnet. And then we'll fill in the broadcast and host range for each subnet. So let's take a look. We have our /24 wheel in front of us. I know that LAN B is going to be a /25 because we've already determined that. So we're going to give all of the IP addresses on that side of the wheel, the first half, to LAN B. It starts at .0 for its network. Now, we know that LAN B has a total of 128 IP addresses. So I add 128 to the network IP of .0 and I get 128. 0 plus 128 is 128. So that gives me my starting point for my next subnet. Now I'm going to figure out what do I need to do from here. So LAN C is coming up next. It needs a total of 32 IP addresses. I add 32 to 128. 128 plus 32 gives me 160, which is the network IP for my next subnet. So now I've kind of got LAN C delineated there. So LAN C is a /27. And now I'm going to take a look at LAN A. LAN A is going to be a /29. It requires 8. So I'm going to take 160 plus 8, and that would give me 168. That would be the IP address for the next subnet. Now, LAN A /29, I can see where that range, the kind of the size of that range. When you slice and dice the pie, it doesn't have to be exact. It gives you kind of a feeling of where you are and what IP addresses are remaining. All right, looks good so far. Now that we know the network IPs or the starting points for the 3 subnets, I need to find their broadcast. So if we take a look at LAN B, the broadcast is 127. The broadcast of LAN C is, well, let's actually stay in LAN B. So if my broadcast is 127, the first host is going to be .1, and the last host would be .126. So those are the IP addresses I can actually assign to devices, anything between 1 and 126. In LAN C, my broadcast is 159. That means my host range would be from 129 to 158. LAN A, so my broadcast is going to be 167. And the usable host IPs between that would be 161 through 166. Excellent. Okay. You might be wondering, what about all these other IPs that we're not using? That's right. We are not allowed to use those. We've not defined them in our current subnets. So even if I run out of IP addresses in LAN A and I need a couple more, I couldn't just go and grab some that aren't being used. I would have to uh, reconfigure our subnets and make sure that I use the correct subnet mask to identify the size of the network. And I'd have to make sure that I start at a valid network starting point. So it's possible, but you do need to reconfigure with the correct steps. You can't just grab an IP address, let's say something like 203 or something like that. You can say, oh, I'll just use that since it's not being used, and I'll put that in LAN B or LAN C or LAN A. The router is not going to be happy with that at all because the router knows exactly how big your segments are. Great. So we've kind of got this picture in our mind, or maybe we've drawn it out of our subnetting wheel. And now what we want to do is we want to be able to transfer that into an IP addressing table. So that's step 5, creating an IP address table for our solution. So we have to remember we're given 192.168.5.0 /24 as our starting point. And so now we're going to take a look at the table. So what we do for LAN B, our network IP is .0. Our first host is .1. Our last host is 126. Our broadcast is 127. And of course, our subnet mask, it was a /25 network. All right, we just continue filling out the table then. For LAN C, the network IP was 129. First host 128. 128 is our network. First host 129, last host 158, and broadcast 159. And this is a /27 network. LAN A, of course, started at 160 for our network IP, and then our first IP, host IP, would be 161, last host 166, and of course the broadcast was 167, and that was a /29 network. Remember, we cannot give network IPs and broadcast IPs to devices on our networks. We can only use the ranges between the first host and the last host. All right. Also take a look at that subnet mask column. Notice how they're all different, as 25 to 27, a /29. That is VLSM. That's the difference between VLSM and traditional subnetting. Traditional subnetting, they'd all be the same. They'd all be the same subnet. Everybody would be equal. But that's not really how modern networks work today. We all basically right size our networks. We make that subnet the size that it needs to, and assign the appropriate range of IP addresses for each network that we have. All right. Step 6, the final step really is if we were actually going to take our table and apply it. So we've made the plan, and this would be how we work the plan. So we would assign IP addresses to our devices. Remember LAN A, as just a review, those are the host IPs, 161 to 166. LAN B was from .1 to 126, and LAN C was from .129 to 158. So the first thing I like to do is I like to give my routers their IP addresses. So you notice there are 3 cables going into the routers, and those are connected at the router interfaces. And so the first router interface is going to get the IP address 192.168.5.158. I could have picked any of these IP addresses from LAN C. I just decided to choose the last host. Now, the router is going to get a second IP address at that interface. And once again, I've used the last host for LAN B, 192.168.5.126. And then the third interface is going to get 192.168.5.166, which is the last host IP in LAN A. So I've got my router IP addresses defined. Remember, those are my default gateways. The router IPs are the default gateways. All right. So if we actually had to create an IP address for one of our hosts on the network here, we could do that. So let's take a look at this PC. If we wanted to assign an IP address to it, I would just make sure that the IP address was in the range between 129 and 157, because I've already used 158 on the router, so I can't give that to a PC. This PC, I could say, oh, your IP address is .135. Your subnet mask is for a /27, so it's 255.255.255.224. And the default gateway is the router's IP, 192.168.5.158. Awesome, looks great. Let's see what it would look like to assign an IP address from a different network. So we pop over to LAN B. LAN B, I can give the IP address as long as it's in the range between 1 and 125, because I've given 126 to the router already, so I can't have duplicate IPs on my network. So I've given it .10, 192.168.5.10. All right, it is a /25 network, so 255.255.255.128 becomes my subnet mask, and my default gateway is the router's IP. So I just reference what I've already assigned to the router, 192.168.5.126. All right, looks great. So here's a problem for you to subnet on your own. So we are given the /24 network of 10.1.1.0. You are to use VLSM to create 3 subnets for LAN A, B, and WAN X. So LAN A needs 100 IP addresses. LAN B needs 40 IP addresses. WAN X needs 2 IP addresses. So go ahead and pause the video, and when you return, I will work the problem with you. All right, we are going to work the solution here. There's various ways to do subnetting. This is just a way that I use. It's very visual. It's great when I was just learning subnetting. So as you master subnetting, you may find other methods. So this is just one way of kind of finding out how I could subnet the subnet the 1/24 to 3 networks. So first of all, what I think of is kind of going through my list. I go from LAN A, LAN B, and my network X, my LAN X, and I recall that A needed 100 hosts, B needed 40 hosts, X needed 2. All right, so I look at my cheat sheet and I look at 100 IP addresses and I determine that the best network for that is going to be a /25. Then I look at 40. So the best network for that, the best size for that is going to be a /26. And the very best network for a WAN, a point-to-point connection, is going to be a /30, where I only just need 2 IP addresses. So I'm going to say that that's going to be a /30. Now I also want to record the total number of IP addresses. So a /25 has 128 total IPs, a /26 has 64, and a /30 has 4 IP addresses. Remember, those numbers are going to help me find my IP addresses, my network IP addresses to start each range. So the other thing that was given to us was our starting point. So our starting point was 10.1.1.0/24. So that's where I'm starting. There's my wheel, and I'm ready to slice and dice it a little bit. So first, /25. I'm going to make a /25 by dividing this, and this is going to be my /25 for network A. So LAN A is going to get that. I know that I always start at 0. 0 plus 128 gives me 128. That's my starting point for my next network. Now I know that B is going to be starting here, and I look at B. B is going to be a /26, which is 64. So I take 128 and I add it to 64, and that gives me 192. And I know a /26 is about a fourth of that pie, so I'm just going to draw that out here. And 128 plus 64 gives me 192. Remember, 192 is the start of the next subnet. It's a network IP. So that's actually where my X is going to be starting with there. And X needs 4. So 192 plus 4 is going to give me 196. So I'll put that out here. There's my next IP address. If I had other subnets, that's where they would start. So I have my network IP addresses. I'm going to just actually start them in the table right now. So my network IP for LAN A is 10.1.1.0. My network IP for LAN B is 10.1.1.128. And my network IP for my WAN X is 10.1.1.192. All right. First host then of A, right? First host of A is .1. So I'm just going to write .1 there. My last host, I'm going to have to find the last 2 numbers here. Obviously, my broadcast is 127. That means my last host has to be 126. So last host 126, broadcast 127. And my subnet mask, we already determined is going to be a /25. So I could look at my cheat sheet, 255.255.255.128. So remember, that's a /25. All right, LAN B. LAN B, the first host is always 1 greater, right? 1 greater than the network IP, so that's going to be 129. So 128 to 129. That's my first host. And then I come over here, my last host and my broadcast. So my broadcast is 191. If I just subtract 1 from 192, that's going to be 191. That means my last host is 190. So there's my last host. Perfect. And this is going to be a /26. So 255.255.192. That's going to be a /26. So thank you. The idea here, but I'll just pen those in real quickly. All right, so now I'm starting on WAN X. So X, it starts at 192. Here's what's really interesting. A /30 is only 4 IP addresses. I've got 4 fingers that I could count on. It makes it pretty easy. So if I start with 192, my first host is going to be 193. My last host is 194. My broadcast is 195. they just go in order. 192, 193, 194, 195. Those are the 4 IP addresses, total IPs. 1, 2, 3, 4, right? 4 IPs and a /30. So that looks like I am good to go. And my subnet mask for a /30, once again, you can just grab your subnetting cheat sheet. It's 255.255.255.252. That's a /30. All right, that looks fantastic. So we just review the solution. We know that the /25, that we had usable hosts between 1 and 126. LAN B gave us usable hosts between 129 and 191. And our WAN X really just had 2 usable hosts, 193 and 194. All right, we made it through subnetting level 14. You rock.